Hey guys, so today we are going to be talking about prediction intervals. Um so far what we've been doing for predictions is giving an exact value. So for example, if I wanted to predict the blood pressure of someone who is 30 years old, I would simply do equals forecast 30 and then my dependent variable BB AA, and I would predict that the blood pressure of someone is exactly 131.4. Um, Now, from what we've learned so far, uh, it is very difficult to predict an exact value, right? The chances of someone who is age 30 that will have exactly 131.4 blood pressure is is relatively small, right? And so in order for us to be more accurate with our predictions, we are going to be moving away from just predicting one point and giving a prediction interval, which means that we are going to be predicting that someone who has the blood pressure of age 30, their blood pressure will be between some two numbers. Um, and so let me switch over. Our prediction intervals will be in the form of y hat minus e is less than y hat is less than y hat plus e. And this should look somewhat familiar. We dealt with this way back in January and a little bit of February with confidence intervals. Um, Back then we were predicting the mean, right? We were predicting that the mean of a population is going to be between some two numbers. This time, instead of predicting the mean of something, we are giving a prediction to the future or some scenario that is happening, that it will fall between some two numbers. Um, y hat, we've already learned, is our prediction, right? So, as we just mentioned, the prediction for someone who is age 30 will have a blood pressure of 131.4. So my y hat for the age of 30 is 131.4. And now we just need to figure out what E is. And this will be a somewhat complicated equation, and there will be a part where you will need to do by hand. And so let's write down the equation for the margin of error. This will be at the bottom of page 279 if you have your workbooks, or if you just printed out the page. It's on the very first page of section 9.4. Um, the equation for margin of error is, that's a really big one. E is equal to, and I'm going to use different colors for different parts. We have TC, our critical value, our critical T value. We have SE, which is our standard error, which we already learned how to calculate in the previous video. And we have the square root of 1 plus 1 over n plus n x0 minus x bar squared all over n times the sum of x squared plus the sum of x squared. Let me just double check. Oh, sorry, this bottom part is a minus. Okay. Uh, and so this should, again, the bottom, especially the denominator of this fraction, should look somewhat familiar. We've already kind of worked with it a little bit when we were talking about the uh, correlation coefficients and linear regression with finding the slope. So we've already seen the bottom part of this before. Um, the top part, we have a new variable xo. Let me use a different color for this. Let's just go with black. XO. What XO is the independent variable value that we are trying to predict. The prediction value, I guess, is what we'll call it. The prediction value. So in our previous example with blood pressure and age, we are predicting the blood pressure of someone who is age 30. So 30 will be our x0. X0 will be given generally. I will pretty much always give you x0 to ask you to predict something at this value. The given value will be x0. X bar, anytime you see something with a bar on top, that's the average. So that's just the average of x. These first two values we can do through Google Sheets. That's not too big of an issue. However, this back part, it might be more convenient to do by hand with a calculator. I will also show you how to do it through Google Sheets, but it might be more useful to break this up into 3 separate calculations and then add it all up and then square root it. I would recommend against trying to do all 3 of these things at once. It is a lot, and so I would recommend just doing it part by part. And so SE, we already figured out how to do that using Google Sheets last video. That is the equals STEYX formula. And we just put the dependent variable here and independent variable second. And so we already learned how to do that part. The confidence T level, or the critical value for a T value using confidence. On your T tables, you, again, going back to what we've done previously, rather than using one-tailed or two-tailed, I will give you a confidence level. So for example, I might say I want to be 95% confident, or I might say I want to be 90% confident, or I might say I want to be 99% confident. In any case, you can use that to find a value using your t-table. Alternatively, you will need to divide 1 minus confidence value, 1 minus confidence level, divide that by 2, and use the two-tailed value for that. Let me show you what I mean. Remember that the confidence value is the number that is inside here, right? So 95%. So if I'm 95% confidence, then that means this is essentially the same as a two-tailed test with 2.5% on each side, right? 2.5. Essentially, this is the same as a two-tailed test with alpha equals 5%. If I am 90% confidence, let me draw this out. If I am 90% confident, and there's 5% on each side, 5% This is essentially the same as a two-tailed test with 10% with alpha equals 10%, right? 0.1. So again, we can't interchange between these, or you can just use the confidence level to find it on your t-table that you have. Okay, so we're going to be talking about the 6 steps to use the prediction interval. And these steps can be written down on pages, I believe, 280 and 281. So you can write those down so that you can refer to it. So our first step is to identify our degree of freedom and our level of confidence. Identify degree of freedom and level of confidence C. Our second step is to use that to find our critical value. Find the critical value on your t-table. Or I will show you how to do this on Google Sheets. On your t-table, you might have some confidence level of, say, 0.95 here. And if your degree of freedom is 15, you would find a value right here. So that's one way you can do it. Again, I'll show you how to do it on Google Sheets. Step 3. Step 3, we are going to find our y-hat. Use the line of best fit, or you can use equals forecast to find y-hat. Again, you can use either method. It's really up to you which one you prefer. But both will work. Step 4. Step 4, we are going to calculate the standard error, and this will be your SE. Calculate standard error. So this is your SE, and this is your TC. On the previous page, these are these two numbers. Finally, we're gonna put it all together. Calculate the margin of error, and that essentially means plugging in the numbers into this formula. And finally, use y-hat and margin of error to find your endpoints. So this is your y-hat minus E, y-hat plus E. All right, so that's pretty much all the methodology you need to know. So now I'm gonna run through some examples with you guys. So let me switch over to my Google Sheets, and let's have this up on the side. Okay, we don't need all that. Okay. Yeah, this should be fine over there. And I will zoom in a little bit. Let's go with 150. Should be fine. Okay. All right, so this example is in your book. It is page 280 and 281. So you can follow along using those 2 pages. All right, and so the first step is to find my degree of freedom and my level of confidence. My degree of freedom is n minus 2. So I'm going to count out how many there are. There's 8 data values minus 2. My df is equal to 6. And I'm going to align this on the... Okay, so my degree of freedom is 6. Next up, I need to find my level of confidence. On page 281, I'm looking for a 95% prediction interval. So I'm going to use C is equal to 95%. If you look at your t-table, again, you can use your t-table confidence level of 95 and degree of freedom of 6. If you are using Google Sheets, you can do t.inverse two-tailed. 100% minus 5 is 5%, so 0.05. And with a degree of freedom of 6. So I'm just going to do 6. And so my TC will be 2.44 or 2.45. This is my TC. Let me stick that there. Okay. So that solves my first 2 steps. My next step is to find the line of best fit to find y hat, using the line of best fit to find y hat. So let me do that over here. Y hat is equal to, just make sure you guys can still see that. Yep. My y hat is equal to, I'm just going to use forecast. I'm trying to find when x is equal to 26 minutes. So x is 26. My data y is b, my data x is a, and so my y hat is 41.8. That is my current prediction. Of course, the chances of it being exactly 41.824 is pretty much impossible, right? It's so hard to get something to be that exact when you're predicting things. And so we're gonna need to find our margin of error. Next step, I'm gonna need to find the standard error. So SE. Again, let me put this on the left side. This is equal to the standard error of YX. Again, BB, AA, and we got it. And so that ends step 4. We got this critical value, we got a standard error, and now we need to do the long equation. And so I'm gonna just make this into several parts. Down here, yep, down here I'm gonna have, let me move all this a little bit. I want to have a column for x squared. So this is equal to this x squared autofill, and I'm gonna sum up these things. Sum it up and sum it up. So this is my sum of x, and this is my sum of x squared. Just to label these, I'm just gonna label these for this one, just so you know what I'm doing. I'm gonna go back to this formula. All right. And so we already have TC and SE. And so all we need to do now is to calculate the square root number that is in red. So first, 1 plus 1 over n, I'm not too concerned about that. Let me also make sure that this is not 7. This only goes to A2 to A9. There we go. Yep. Okay. So let me do the complicated fraction first. So the numerator is going to be n. So I know n is 8. 1, 2, 3, 4, 5, 6, 7, 8. So it is equal, whoops. My numerator is equal to 8 times, and I want x0. So x0 is whatever I'm trying to predict, right? I'm trying to predict at 26 minutes, so x0 is 26 minus the mean of x, so the average of A2 to A9, and I want to square this whole thing. 8 times 26 minus the average of my x values squared. So that is my numerator. My denominator, denominator, I think I spelled that right, is equal to n. Again, I know that's 1, 2, 3, 4, 5, 6, 7, 8. 8 times the sum of x squared, which is this one, minus the sum of x, which is this one, to the power of 2. And again, just gonna enter that, and I have my fraction. So now let's put it all together. Full square root. This is equal to the square root of 1 plus 1 over n, so 1 over 8, plus, and then I can just do the numerator divided by the denominator. Again, if you find that it is easier to do all of this on a calculator where you can actually see the fractions, go for it. I'm not gonna stop you there. And so my full square root is 1.11. Let me move this away. Sorry about that. I didn't realize that that was blocking. Let me move this over. There we go. And so my margin of error is equal to 3 numbers multiplied together, right? So I have my TC up here, multiplied by my SE, multiplied by my full square root down here. And so my margin of error is 16.88 about. These two things, I'm just going to reduce it to 2 decimal points. I don't need more than that. And so how I will write my answer will be, on the lower end, it's going to be y hat, which is up here, minus the margin of error. On my higher end, it's going to be my y hat plus my margin of error. And so my final answer, if I'm writing this on a piece of paper, will be 24.94 is less than y hat is, yeah, less than y hat is less than 58.70. What does this mean? Well, it means that I will be 90%, 95% confident that if we spend 26 minutes advertising on TV, our sales will be somewhere between 24.94 and 58.7. Our sales will be somewhere between those, and I'm 95% confident about that. So that was one example. We'll do another one, and this one is also in your book. It is on the next page, which is 282. It relates baby weight and the numbers of hours of sleep. I'm gonna run through this a little bit faster, just to show you how fast you can do this if you understand what you are doing. So up here, I'm gonna do my, I'm gonna see how many there are. There are 1, 2, 3, 4, 5, 6, 7, 8. There's 8, and so my degree of freedom is 6. So this is my N and DF. Just to note that to myself. My confidence level that they are asking me about from the book is 99% confident, 99%, which means that my t value is going to be t dot inverse dot 2t 0.01, because that's what's left, and degree of freedom is 6. So my TC is 3.7. My standard error, STEYX of BBAA, is 0.57. So there we go. We got the first part done. I'm also gonna forecast. I want to test the baby weight of 10.4, dependent, independent. So that's my y hat. Y hat. So far that should be good. These are the numbers that I will multiply. So I'm just gonna quickly label that. And that's the number I'm gonna add and subtract from. I'm not gonna move those, so let me quickly. So the sum of x is equal to the sum of AA. I'm gonna square these things real quick. Oops. Equals this thing squared. There we go. Autofill. So sum of x squared is equal to sum of these things. And so my square root, look at my formula, I have a numerator of n, which is 8 times 10.4, that's what I'm predicting, minus the average of my A2 to A9 squared. My denominator is equal to 8 times the x squared, which is this one. Let me put that in parentheses. Minus the sum of x, which is up here, squared. My final square root is equal to the square root of 1 plus 1 over 8 plus the numerator divided by the denominator of that weird fraction. And finally, I can multiply it all together. For my margin of error is this one times this one times this one. So my margin of error is about 2.26. Again, I'm going to lower the decimal points there. So on my lower end, I'm going to have y hat minus the margin of error. On the higher end, I'm going to have y hat plus my margin of error. And so in my answers, if I'm writing this on paper, so let me do this in green, it'll be 11.27 y hat 15.80. And so again, let's interpret this real quick. A baby that has a weight of 10.4 ounces will sleep somewhere between 11.27 hours and 15.8 hours. And we are 99% confidence in this. Yep. And so those are the two examples that are in your workbook. I'm going to show you two more examples that you might use for your homework. One is age and blood pressure that we've already done, and months since 1992 and beef prices. Again, two data sets that we've been using over and over again in this class, and so these two should not come as much of a surprise. And so again, if you are feeling okay with this and you don't need any extra examples, you can go ahead and pause the video, leave it, close it, and go work on your homework. If you feel like you need some more examples that I'm walking through, then you can stay and watch some more. Once again, I'm just gonna count AA. There's 10 numbers there. And so my degree of freedom is n minus 2, which is 8. I'm just gonna calculate TC. Let's just say I'm doing 95% for both of these. So TC will be equal to T inverse 2T. There's 5% left. So 0.05. Degrees of freedom is 8. My standard error, STEYX of BBAA, and my Y hat is equal to forecast. Let's predict a 30-year-old, right? Again, I'm just kind of making these numbers up. On your homework, it'll be very clear what your X0 is going to be. Anyways, let me quickly do that. Forecast B30 BBAA. So again, it's really difficult to say that a person will have an exact blood pressure of 131.4. It's usually more common that we're going to give a range of numbers, which is what we are going to do now. I'm going to go ahead and square all these. Oops, I did an autofill, so I'll just click and drag. That's fine. So we have, what do we need? We need the sum of x. So that is equal to the sum of A. We need the sum of x squared, which is my C column. Sum of C. I need my numerator, which is equal to 10. That's my n up there, times the x0, so 30. That's what we're predicting, minus the average of A squared. Denominator is 10 times the sum of x squared, which is up here. Oops. 10 times this number up here minus this number up here to the power of 2. Final square root is equal to 1 plus, let me go back and look at the formula. So 1 plus 1 minus n, so 1 over 10, plus the numerator divided by the denominator of this weird fraction. My margin of error is going to be these three numbers multiplied by each other, so this times this times this. 38.05. I'm going to go ahead. My lower value will be 93. My higher value will be 169.4. So my answer is that a 30-year-old, I will be 95% confident in saying that the blood pressure of a 30-year-old is between 93.36 and 169.48. I am 95% confident in saying that. Final one. One final example. This one is a big one, as most of you have already experienced this data sheet. And it doesn't matter how big the data is, we can still use the same process. So first, I'm going to count how many there are. And it's going to be this one minus 2 for my degree of freedom. Again, we're going to go ahead and just do 95%. My TC will then be T dot inverse dot 2T, 0.05. Degree of freedom is 345. My standard error, STEYX, BBAA, and my Y hat for my predictions, forecast, we'll just go with a random number. Let's say I want to predict 400 months. Let's say I want to predict 400 months after 1992. Equals forecast 400 comma BB AA dependent independent 5.17. I'm gonna go ahead and square all my numbers here. It didn't autofill, that's fine. I'm just gonna click and drag. It's gonna take a second, but that's okay. Oops, went past it. Oh. Sum of x is equal to the sum of AA. Sum of x squared is equal to sum of my C column. Now I'll have to do the numerator and denominator. Again, for this fraction, if you find it easier to do it on a calculator and just go straight to the final square root, whatever that is, you can do that. I have no good way of showing you how to input it into your calculator, so that's why I'm just showing it to you on Google Sheets. This is the n is 347 times x0, which is 400, minus the average of AA squared. That's a big number. The denominator is equal to n, so 347. Let me do this in parentheses, times the sum of x squared, so this number, minus the sum of x to the power of 2. Good. We can now do our final square root, SQRT, 1 plus 1 over 347 plus the numerator divided by the denominator. 1.0076. So basically it's essentially multiplied by 1. So my error is equal to this times this times this. On my lower end, I'm gonna have y hat minus the error. On my higher end, I have equals to y hat plus my error. And so what does this mean? It means that 400 months after 1992, I will be 95% confident in saying that the price of beef will be somewhere between $3.76 and $6.59 or $6.60. I am 95% confident in saying that. The best thing about doing it in this method is that if I want to be 99% confident, I only need to change this number. So if I want to be 99% confidence, which means alpha is 0.01, everything else automatically changes for me. So that's one advantage of doing it this way, is that you can easily change just one number, and the rest of the numbers will automatically change for me. So that's all of my examples. You can let me know if you have any questions about this. I'll be in the Google Meet during normal class time, and we'll go through this again on Monday and Tuesday to prepare for the test on Thursday and Friday. So let me know if you have any questions, either through email or through a comment, and I'll try to get back to you as soon as possible.